Good morning students. Today is the 31st class on digital land surveying and mapping. In this class I will be talking on fundamentals of mapping. Now you know that the objective of surveying is to prepare the plan or map of the area, and I will be discussing before making the plan or map of the area. In fact, before doing the surveying we need to know some of the fundamentals, or we need to consider some of the primary considerations that has to be taken up in mapping the area. So this is what will be discussed today, and the topic will be discussed under following heads. That first I will like to know why really we need to know these fundamentals, and then the different consideration for these fundamentals and the need for that. Now we know that the surface of the earth is curved, whereas the surface of the map or the plane of the paper on which we do represent our surface of the earth is a plane area. So in analytical term we can say that the 3D earth surface object will be need to be represented in a 2D map surface. Now not only that our surface of the earth is abound with plethora of information. Now many of the informations may be useful for our purpose and many may not, and also sometimes some of the information, though it is useful, but there is some other problem while we will going for preparing the map, and we maybe need to know which information has to be maintained and which has to be taken out. So there are so many issues that will come up. Now above and above that there are so many other considerations which we need to do about mapping before we start our surveying. So the fundamentals behind the mapping has to be understood before we carry out the surveying, and also we should know what are the requirements of the mapping, or what are the use of the map or the outcome of the surveying has to be also ascertained before we start the surveying work. But if we summarize all of the things, we can come down to three aspects like the scale, plotting accuracy and generation of detail. These are the three main aspects really we should understand with reference to map making, and in particular to particular surveying work which we will be conducting for preparing the map. And now the map scale, the scale. Now already we had discussed that there are scale of map, scale by scale of map. Generally we understand that the scale is the for planimetric scale, scale for planimetric positioning or planimetric representation. And as you know that our topographic map will be considering the representation of 3D earth object in a 2D object, and also in last classes I had discussed about the representation of third dimension, that is the vertical height through contours. And another thing which related to vertical scale is that contour interval. So now at present in this class I will be restricting my discussion on the scale related to planimetric representation. Now what is the scale? Now by scale what we mean, suppose there is an line A and B which is 100 meter length in the field, and this line is represented by a line AB of length 10 centimeter in map. This is the field, this is the field line, and this is the map line. Now that means 10 centimeter of the map, we represent a length of 100 meter in the field. So we call that 1 centimeter equivalent to 10 meter. So this is the scale of the map. Sometimes also we represent by some other way, like 100 meter means we can say this is the 10,000 centimeter. So the scale is 1:1000. So this is another way how we do represent. So this is called representative fraction. So representative fraction, that means 1/1000. So this is the representative fraction by which we do represent a scale of a, that is the planimetric scale, and sometimes we do represent it by a unit like this. This is called equivalence scale. Equivalence scale. In equivalence scale we do represent a small distance, which is the first distance, this is the map distance, and the equivalent distance in the field distance, this is field distance. Apart from this, there is another way how we can provide the scale in a map, that is called graphical method or graphical scale. Graphical scale. Now what is the graphical scale? In the map, in the legend box, we will draw a line of length, suppose 20 centimeter I have drawn, 0, 10, 20, actual length is 20 centimeter, but I will write it 0, 100 meter, 200 meter. So actual length is 10 centimeter and 20 centimeter, but as my scale is 1 centimeter to 10 meter, so 10 centimeter will be 100 meter. So this is the graphical scale or graphical representation of the scale. So in these three ways how we can number one is that representative fraction scale or equivalence term or graphical term. There are three ways how we can represent the planimetric scale in a map. Now of these three, actually the graphical scale is the most accurate. The reason behind is that one thing is that we can draw the distance more accurately and we can see and we can give it to the map. Another point which is important with the graphical scale is that, or if we take any copy of the map, the amount of enlargement or reduction of the map will be same as the enlargement or reduction in size of this graphical scale. So all these will give us the measurement in distance of the map using graphical scale more accurate than other scale. So generally we prefer the graphical scale, but however in most cases also we find that representative fraction is also mentioned in the map. Now this scale, so scale of map. Now this is a very important issue with respect to the map, because this is the way how we are representing the actual surface of the earth on a defined map surface. So now it is not that simple to do. There are many factors on which the scale of map has to be chosen. Actually we have to choose what is the scale of the map or scale at which we will represent the surface of the earth, and depending upon the scale of the map, actually scale also represent the accuracy of presentation, as well as it will represent the accuracy of our measurement. So whole gamut of our surveying, planning, all these things, what is the method of measurement, what will be the instrument to measure, what will be the accuracy of measurement, what is the quality of the measurement, all these will follow the scale of map. So scale of map we should understood very clearly, and its significance has to be understood nicely before we carry out any surveying work. Now the factors which really guides the scale of map, the most important thing is the purpose. That means what is the purpose for which we are going to use the map. This is the most important thing which will guide about the selection of a map. And apart from that, another important is nature of the terrain, and nature of terrain, and then also what is the accuracy or precision of the map we are looking for of map. So these are the three important factors which guides the selection of the map. Of course there are so many other small criteria which has to be considered beyond this to select our scale of map, like what are the resources available and many other things like that. Now purpose of the map. Now we may make use of map for design or artwork. For design and artwork, design work or artwork, we need more accurate or precision map. So whenever we will like to have our map to be used for design purpose or map artwork purpose, we need to have more precise and accurate map, and in those cases our scale should be large. Purpose is like our planning purpose or some location purpose, then we may go for our map in a smaller scale. Nature of terrain, as we can see that if the terrain is very smooth, plain, then we may go for quite large scale because the variations will not be much. On the other hand, if the terrain is very stiff or undulating, then we should go for large scale, so that we can go for more precise presentation of the heights and all these things. Again, not only the physiography, also what is the physiography as well as cultural detail. Physiography as cultural detail. If the cultural details are more, then we will not be able to go for very accurate or very precise presentation of so many things. So then we have to go for very large scale. But what we find that these factors are mutually contradicting. That means if we want to serve the purpose of the map properly, then maybe we will be doing injustice to the criteria that nature of terrain really demands. So anyway, or sometimes we will not be able to take care of the accuracy which really we are looking for if we want to do justice to the nature of terrain. Even if they are contradictory, so there lies the utility of the engineer in charge to select the consideration of the scale of map. Now the scale of map is basically we do define into three classes, that is called large scale, then medium scale, and then our small scale. Now large scale, actually there is no hard and fast rule for that, but generally whenever the scale is 1:2400 or larger means lower representative fraction like 1:100 or 1:1000. So these are larger scale than 1:2014. So if the scale lies between the scale is larger than 1:2000, then we call that the large scale map, and if the scale varies from 1 is to 12,000 to 1 is to 400, then we say that this is the medium scale, and if the scale is still smaller than 1 is to 12,000, then we call it small scale. Now the significance of this terminology is that depending upon our purpose, we, as I have told you, that we have to say whether we will look for the small scale or medium scale or larger scale. Now whenever we will go for high accuracy work, we should go for large scale map. Like if we want to go for earthwork, or if we want to go for building design or laying or any important construction work, then we should go for large scale map. But when if we go for planning purpose, then like a big huge amount of area is involved, and we want to do any civil engineering project like laying of a dam, something like that, or reservoir. So that case we should go for medium scale, and small scale generally we go for when the area to be considered is a huge area and we want to get a synoptic view of the area, or so many area we have to take together, then we will go for small scale mapping. So depending upon the purpose, we have to go different types of scales. But one thing is important or also very much encouraging is that if we prepare the map in digital form, then we can have our scale modified as and when required if the measurements taken are of very high quality. So that is the utility of digital land surveying and mapping, that we during the surveying we should take our data as best as possible or as best as available, or the instrumentation and methods and the resources, and then subsequently we can make use of the data for the type of map, scale of map, class of map, whatever we require from time to time, simply by using the different formats. So that is the beauty and the advantage of having digital map. So in true sense, this thing will not have much bearing on digital land surveying and mapping if we go for very sophisticated way of collecting the data using digital precise instruments. And then another point which is important about the map is that the accuracy. As I have told you, what is the accuracy of the map? Actually, accuracy of map depends on what is the dimension of plotting or drafting. So also it depends on scale. So scale and the dimension of plotting or graphics is called, these two provides the accuracy of the map. Let us take an example using a dimension of 0.2 millimeter to represent our object, and the scale of the map is 1:1000. So what will be the least dimension of the object we will be able to represent? Simply we multiply this thing, that means 200 millimeter. So and 200 millimeter means 20 centimeter, 0.2 meter. So that is the least dimension of the object, least dimension of the object, least dimension of the object which we will be able to represent in the map. So this is the accuracy of the map, or the precision with which we can represent the map object in the map. Now you can see here that depending upon what will be the dimension of the objects for our purpose, indirectly because this is the dimension of the plotting of this, more or less it is constant, because the if we go for automated presentation or computer oriented, there is a restricted dimension to which we can go for. And also if we make use of still smaller, maybe sometimes we will not be able to recognize it. So maybe 0.2 millimeter dimension, if there is a point, also we will not be able to recognize, but if there is a line of 0.2 millimeter dimension, then we will be able to recognize. So also that is another important factor. We cannot arbitrarily take the dimension of plotting. For point we can take, we have to take a bigger dimension. For line we can go for smaller dimension, but that dimension that should be perceptible to human eye. So in this way we can restrict the dimension of the object which we will be able to acquire from the field during our surveying. So before we go to the field for our surveying work, we need to decide the scale, then only, and also we should have the knowledge about the dimension of plotting, and from these two we have to correlate and to find out what should be the minimum dimension of the object which we will be able to acquire from the field. Now sometimes we will find that some of the objects even smaller than the minimum permissible object dimension, but some of the objects still we will be in need to take up because of the requirement of our project. Now suppose the scale of the map, suppose let us take the scale of the map is 1:10,000, then the dimension of minimum dimension of the object will be 2 meter. Now if we want to carry for road project, and you will see in the village we will find many of these roads having dimension less than 2 meter, but these are the roads which we like to show in our map, because we are carrying out the surveying for road project. So what to do, how to do? So that is, then there lies the concept of generalization of detail. And if we and most of the objects or features that is available on the surface of the earth, many of the objects we have to represent in the map, and generally we represent the objects in the map using some symbols, and symbols will have some dimension. So if the dimension of the symbols are more, generally dimensions of the symbols will be much bigger than the size of the object that can be represented in the map. Now if we consider an object which is having a symbol dimension of 2 centimeter by 2 centimeter, now for a scale of map 1:10,000, the size of the object will be 20,000 centimeter, which is equal to 200 meter in the field. Now field, and hardly there is any object like road, railway line, many other important thing which really we will like to have in our map having the dimension more than 200 meter. In fact, most of the objects will be having dimension less than 200 meter. So under those circumstances we will not be able to depict these objects, but these are important for our purpose of the work. So solution lies in generalization of detail. Now what is that generalization of detail? In generalization detail we do provide emphasis to the objects or information which are important for us, and we without the information which are not required for the particular purpose for which we are going for surveying. So the representation of important feature is done by the conventional sign I have discussed. So the salient points required for generalizations are choice of features in connection with its purpose and scale of map, elimination of terrain details that cannot be maintained because of the legibility and clarity in the map, and significance of the form of terrain details cannot be omitted, and but of which detailed representation would interfere with the image of the map. So, a topographical map, even a large scale engineering survey map, therefore may not contain all the details that are present on the actual surface of the earth. So, with this I like to conclude today's class. So, now the summarization of this today's class is that the primary objective of surveying is to prepare a planar map. Map is nothing but a 3D object to be present in a 2D plane surface. Of the defined characteristics of map, the map scale is the most important characteristics or considerations to be done. Map scale is to be chosen after taking into consideration of defined conflicting factors like nature of terrain, scale, purpose and all these things. Based on the scale, amount of scale, there are 3 classes of map like large scale map, medium scale map and small scale map. And the accuracy of a map depends on the scale chosen for it, and many of the details of the surface of the earth, the details that are present on the surface of the earth has to be considered under the concept of generalization of detail to omit or to maintain in the map. With this I like to conclude today's class. Next class I will like to talk on some basics of mapping. Thank you.